14.37. Russia initially seized these tanks following its annexation of the peninsula, although they were returned to the Ukrainian government in June. 37. T-64s were used by both Ukraine and the pro-Russian separatists during 2022 Russian invasion of Ukraine. 41. 42. During the early phases of the invasion, Russian forces captured a number of Ukrainian T-64s, which they passed on to the separatists. 37. By the end of 2022, the Ukrainian army had lost 276 T-64s either captured or destroyed. 43. Pro-Russian forces had also lost 50 T-64s in 2022. 44. The crews of T-64s have been called upon to act as artillery, leading to shortages in 125mm ammunition. Crews of the T-64 tanks rely on attack helicopters and drones. After firing at a target, they move positions and fire again. If the Russian forces send infantry directly onto the battlefield, then the T-64 crews are required to directly support the infantry. On the 21st of December, 2022, the Biden administration announced an aid package with an extra 100,000 rounds of 125mm tank ammunition for the first time. 45, 46, 47, 48. Other foreign service. 5 T-64s were delivered to UNITA forces at some point during the Angolan Civil War. 49. The origin of these tanks is not clear, but some number of them were also captured by MPLA forces. 50. According to video evidence, at least one was destroyed in combat. 51. The armed forces of the Democratic Republic of the Congo received 25 T-64B1M from late 2016. They were seen in mid-2017 patrolling in Kasai during the Kamwin and Sapu rebellion. 52. Capabilities and limitations. A rather unconventional design. The T-64 had several features which set it apart not only from previous tanks, but from the visually similar T-72, many related to its higher mechanical complexity firepower. The T-64's hydraulic basket autoloader places the projectiles horizontally at the bottom of turret facing towards the center, and the propellant charges vertically along the outer rim of the turret race, front down. By contrast, the T-72's cassette mechanism places the propellant charge on top of the corresponding projectile, also horizontally. Being hydraulic, the basket type created a risk of hydraulic fluid fire if damaged in combat. The cassette, by contrast, is electric. Basket type folds the projectile cradle upwards off the floor and vertically against the projectile cradle to which it is hinged, moving both pieces into the upper turret. Approaching the gun, the projectile cradle is moved forwards, unfolding both cradles and ammunition pieces to a straight line, ready for insertion. The cassette's cradles are fixed stacked propellant on top of projectile, and the two cradle assembly must raise the propellant part above the gun to load the projectile first, then drawing back the mechanical pusher, lowering the propellant part, and inserting it with a second use of the pusher. This increases the time of loading of the T-72 by approximately 1 second. Total loading time is thus -6-13s for T-64/80 against -7-15 of T-72. Because of greater diameter, basket type holds projectile and propellant parts for 6 additional shots over the cassette of T-72, 28 vs 22. Because of greater diameter of projectile cradle ring of the basket type, T-64 and later T-80 have a higher limit to the maximum length of armor-piercing finstabilized discarding sabot, APFSTs, projectiles, providing superior anti-armor performance relative to shorter projectiles used by T-72. The automatic loader of T-64 is more reliable, and less sensitive to jolting when running off-road. It also has a sequence fire mode that feeds the gun with shells of the SAME type in less than 5 seconds. In the modern versions it is also able to turn backwards to keep a good speed at the end of the loading sequence. Early versions of the basket autoloader lacked safety features and were dangerous to veteran crews, especially the gunner, who sits nearby. Limbs could be easily caught in the machinery rotating around the crew, leading to injuries and deaths. A sleeve unknowingly snagged on one of the autoloader's moving parts could also drag a crewman into the apparatus upon firing. 9. The tank commander's cupola provides good vision. The anti-aircraft machine gun can be operated from inside the turret. The commander can also control the main gun sight if necessary. The turret was poorly configured to allow the crew to manually load the gun should the autoloader break. In such situations, rate of fire usually slowed to an abysmal 1 round per minute as the gunner fumbles with the awkward task of working around the broken machine to load the gun. 9. Although 2-piece ammunition allows for fast reloading of the gun in combat, replenishing the autoloader is quite slow. Movement. Because of a lower weight than T-72, by 3 tons, T-64 has slightly superior strategic and operational mobility, less wear and tear on tank transportation equipment, and lower fuel consumption per distance traveled. Driving seems much less exhausting for the crew, thanks to assisted controls and a more flexible suspension. 53. The suspension system featured an entirely new and advanced design, and suffered various failures of unusually high frequency. Due to these problems, teams of civilian mechanics from the T-64 factories were semi-permanent residents of Soviet tank units early in the T-64's initial adoption phase. 54. The 5TDF opposed piston engine, while powerful and compact, was very finicky and prone to malfunctions and fires. Russian expert Viktor Murakhovsky, then a battalion commander in group of Soviet forces in Germany, reflected that in his unit the rate of the engines requiring a major overhaul was close to 1 per tank in a year. He also noted the difficulty of starting this engine, especially in the damp German winters, and that starting aids used by soldiers like the high-pressure air and forward/oil injection, often caused engine fires. Protection. Basket-type autoloader stores, as stated previously, propellant charges vertically, the rear ends almost the same height as the roof of the hull. Combined with greater diameter of the complete autoloader assembly, the overall greater size of this type compared to the cassette significantly increases chance of ammunition being ignited by direct hit of any weapon penetrating into the crew compartment. The problem is largely irrelevant if a full ammunition load outside autoloader is carried, but T-72 carrying only autoloader ammunition is far more survivable than a T-64 in a similar situation thanks to the compact dimensions of cassette-type ammunition storage. Small and lightly constructed rotor wheels of T-64 have been found to be less resistant to anti-tank mines than the larger rotor wheels of T-72 and previous Soviet medium tanks. Because of the small diameter rotor wheels and vertical placement of propellant charges in the autoloader, charges are dangerously exposed against hits penetrating the 85 mm hull side armor, and are located at such height that they are too high to be protected by the rotor wheels, yet too low to be fully protected by the side skirt armor panels. While many previous tanks used 4 or 5 man crews, T-64 and T-72 have crews of 3 men. This allows the 4th man to remain in relative safety away from combat and perform other duties until the tank returns for maintenance and resupply. Potentially, he and other would-be loaders can be reassigned to vehicle maintenance and resupply duty to assist the crews of other returning tanks. improving the quality of maintenance as the crew inside the tanks will likely be exhausted after several hours of operation. Because of smaller physical characteristics thanks to the 3-men and autoloader design, T-64 and T-72 have a lower theoretical logistical footprint than tanks of equal number using a 2-man loader. This decreases the chance of the logistics chain being detected and attacked and decreases potential losses. Counter to the benefit of leaving the fourth crewman in favor of using an automatic loader, this also creates difficulties in immediately replacing an injured crewman while in combat. In comparison with 4-man tanks, there exists a possibility of an injured crewman being dragged from his seat and into the loader's space for immediate treatment of injury while the tank retreats. In more cramped 3-man designs, such empty space is not immediately available and moving between the turret and hull may be more difficult in the first place. There is also an argument that a fourth crewman can replace any other of the 3 in case of injury. However, this possibility can also exist in 3-man designs if redundancy of weapon controls allows for temporary 1-man operation of turret. Because of weight limitations of the powertrain, T-64 had lower overall capacity for improvements which add weight to the tank. Because improvements of armor tend to have a greater cost in weight than, say, replacement of gun optics and turret forward/gun laying drives with more precise versions, this means T-64 suffers greater limitations in terms of protection improvement than the heavier T-72, which was designed with a more durable powertrain from the start. Concerns of 3-man and 4-man maintenance. While having smaller tank crews, 3 versus the usual 4, is advantageous since more tanks can theoretically be fielded using the same number of soldiers, there are also serious downsides. Tanks require frequent maintenance and refueling, and much of this is physical demanding work that several people must work together to accomplish. Most of the time these duties are also performed at the end of a long day of operations, when everyone in the tank is exhausted. Having 1 less crewman for these tasks increases the strain on the remaining 3 men and increases the frequency of botched or skipped maintenance. This problem worsens if the tank's commander is also an officer who must often perform other duties such as high-level meetings, leaving only 2 men to attend to the tank. 55. All of this means that tanks with 3-man crews are more likely to suffer from performance-degrading human exhaustion, and mechanical failures that take longer to fix and that keep the tank from reaching the battlefield. These problems are exacerbated during prolonged time periods of operations. Operators. Map of T-64 operators in blue with former operators in red, current operators. Democratic Republic of the Congo 25 T-64 BV-1 tanks received from Ukraine in 2016. 56, 57, 58. Transnistria. Transnistria 18 T-64 BVs are in service. Russia approximately 4,000 in 1995. In 2014, Russia had approximately 2,000 which it had phased out of service and believed to be slated for destruction. 7, according to NATO. 59, and the United States Department of State. 60. T-64s and T-64 BVs, including ZR. 2017 variants, have been used by pro-Russian forces in the 2022 invasion of Ukraine. 61, 62. Ukraine 2,345 were in service as of 1995. 2,277 as of 2000 and 2,215 as of 2005. 63. Currently, around 800 are in service, 1,000 plus in storage and over 130 from those that are in active service are modernized to T-64 BM Bulat. By August 2019, Ukraine's Kharkiv Armored Vehicle Factory, KHBTZ, had upgraded over 150 T-64BV to the new Model 2017 standard, and the Lviv Armored Vehicle Factory, LBTZ, had started delivering this model as well. 27. In 2020, Ukraine had over 720 T-64BV 2017, T-64B Empulat and T-64BV in service, and 578 T-64 in storage. 64. During the 2022 invasion of Ukraine, some older T-64s and T-64BS have also been spotted. 65. Donetsk People's Republic. Donetsk People's Republic multiple T-64B, T-64BV and T-64BM in service as of 2017. 66. Luhansk People's Republic. Luhansk People's Republic multiple T-64B, T-64BV and T-64BM in service as of 2017. 66. Uzbekistan 100 in service as of 2017. 67. Former operators. Unita 5 used in the Angolan Civil War. The provenance of these tanks is unclear. 49. 50. Soviet Union passed on to successor states. Belarus unknown number in 1990s. All have been scrapped since. Kazakhstan approximately 50 in 2011. 68. All have been scrapped since. Specifications: T-64BV. T-64BV dimensions. Length: gun to the front 9.225 m, 69. Length, without the gun 6.54 m. Breadth, 3.6 m, 69. Height, 2.17 m, 69. Weight, 42.5 t, 69. Crew: 3 men. Commander. Driver. Gunner. Propulsion. Engine, 5 TDF multi-fuel, diesel, kerosene and petrol, with 5 opposed cylinders, 10 piston 13.6 L developing 700 HP, 515 kilowatts, at 2,800 RPM, consumption of 170 to 200 liters per 100 kilometer. Transmission: 2 lateral gearboxes with 7 forward and 1 backward gear. 3 internal tanks for a 740 liters fuel capacity, 2 on the mudguards with 140 liters and 2 droppable 200 liters tanks on the aft end of the chassis. Performance: maximum road speed, 60.5 km per hour. Max off-road speed, 35 km per hour. Power to weight ratio, 16.2 HP /T, 11.9 kilowatt /T. Range, 500 kilometers, 700 kilometers with additional tanks. Ground pressure, 0.9 kgf /cm2, 88 kPa, 12.8 psi. Able to ford in 1.8 m of water without preparation and 5 m with snorkels. Crosses a 2.8 m wide trench. Crosses a 0.8 m high obstacle. Maximum slope 30 degrees. Armament: 125 mm smoothbore to a 46 m1 gun, D81TM, with carousel 6 ETs 40 loader, 28 shots, fire rate 8 shots per minute, 36 embedded shots, 8x9M112M Cobra, NATO code at 8 Songster, 28 shells. Available shells are all fin-stabilized anti-personnel, APAS, version of the 3UOF-36, 3OVF-22, with several perforating abilities. Armor-piercing shells, APFS, 3 UBM-17 or 3 UBM-19 or older ones with a supplementary charge giving them an initial speed of about 1800 m/s. Hollow charge shells, 3 VUK-25 or 3 UBK-21. Coaxial machine gun 7.62 mm